is May 10th at 2:29 p.m. Pacific time, and you are looking at a live view of the upgraded Falcon 9 rocket as it awaits liftoff from the SpaceX launch pad in approximately 17 minutes. Welcome to today's live webcast for the Bangabandhu Satellite-1 mission from Pad 39A at Kennedy Space Center in Florida. My name is Tom Perderio, and I'm a firmware engineer in the avionics department here at SpaceX. Today's launch is a particularly exciting one as we have two important milestones taking place. The first milestone is that the payload, Bangabandhu Satellite-1, will be the first official geostationary communications satellite for the nation of Bangladesh. The second milestone today is that this is the debut of a series of upgrades to Falcon 9 that we're calling Block 5. These upgrades are designed to allow us to reuse each Falcon 9 10 times or more and also reduce refurbishment time between flights. Falcon 9 today will deliver Bangabandhu Satellite-1 to geostationary transfer orbit, also known as GTO. After that, we will be attempting to recover this first stage on Of Course I Still Love You, which is our drone ship currently stationed about 340 nautical miles downrange in the Atlantic Ocean. If successful, this will mark the 25th successful landing for SpaceX. As you can see, we've got a lot to cover in today's webcast, so let's get started.
Hi, I'm Lauren Lyons, and I'm an engineer here in our Flight Reliability Department. Now, for those of you joining us for the first time, just a little bit about Falcon 9. It's a two-stage rocket, each stage having its own engines and its own propellant. The first stage, which is this lower portion here, this is the part of the rocket that generates the tremendous thrust that's necessary in order to get the rocket through the most dense parts of Earth's lower atmosphere and accelerate the second stage and payload up to approximately 48,000 kilometers per hour. This is also the part of the rocket that we're going to be attempting to land on our drone ship after it separates from the second stage, which is sitting on top here. Stage 2 has a single Merlin engine that is optimized to operate in the vacuum of space, and it's going to be responsible for delivering Bangabandhu Sat-1 into its targeted geostationary transfer orbit. Now, at the very, very top of that rocket, that nose cone that you see there is called our payload fairing, and inside of it, Bangabandhu Satellite-1. The fairing is what protects the satellite from aerothermal heating and contamination as we travel through the Earth's atmosphere. But once we get into the vacuum of space, we jettison it, it'll separate from the rocket and fall back down to Earth. Now, if you've been watching our rockets for a while, you notice that Falcon 9 looks visibly different today. Most notably, we have this black inner stage, this black raceway cover, and these black landing legs. This is the color of our improved thermal protection system materials, or TPS as we call it, and it doesn't require painting. The new thermal protection material is a highly flame-resistant felt, which we expect to be more rapidly reusable than the cork that we previously used. Now, all these changes reflect our ongoing efforts to build not just reusable rockets, but rockets that are rapidly reusable. Eventually, we hope that rocket launches will become like commercial airplanes, where the rockets can be flown over and over again with minimal refurbishments in between. We'll talk more about the Block 5 upgrades later in the webcast, but with just a few minutes left before liftoff, let's get a status update.
Hi, I'm Michael Hammersley, a materials engineer in our avionics department, and I'll be bringing you status updates on the vehicle. Falcon 9 rolled out to the pad with the Bangabandhu Satellite-1 payload last night at about 8 p.m. local time, and it went vertical at roughly 8 a.m. local time this morning. We went through the launch director's go, no-go poll, held at about T-minus 2 hours, and we're currently working no issues on the vehicle. One of the several changes to Block 5 is in how we load propellants. We use a liquid kerosene fuel called RP1, and our oxidizer is liquid oxygen. Now, instead of starting with our fuel load at T-minus 70 minutes, we began loading both RP1 and liquid oxygen onto the first stage at T-minus 35 minutes. At the same time, we started loading RP1 onto the second stage. So the first stage is going to be continuing its fill just until a couple minutes before launch. It's at about 80% full of RP1 and, 85% full of RP1 and about 80% of liquid oxygen. The second stage does its propellant loading sequentially. So its RP1 load is actually complete. That was finishing up at about T-minus 22 minutes. And the liquid oxygen load began just a few moments ago, and it's at about 15% loaded at the moment. We pressurize the tanks with helium. Those are at just under 100%. We'll slowly be trickling in additional helium. Those hold the pressure in the tanks when we're emptying the tanks of fuel during ascent. We're also planning on recovering the first stage of today's Falcon 9. The drone ship, Of Course I Still Love You, is currently holding position 340 nautical miles southeast of Kennedy Space Center. And after stage separation around T plus 3.5 minutes or so, or 2.5 minutes or so, excuse me, we should be bringing you live coverage on its way back down. All told, vehicle's healthy at the moment. Payload's also healthy and the range is a go. Weather-wise, we're watching some strong high-altitude winds and some thick cloud layers that are cooling to minus 20 degrees Celsius, but there's nothing that's looking like it's going to stop us from launching in 12 minutes from now.
Block 5 refers to a series of upgrades we've made to the Falcon 9 rocket as part of our ongoing effort to make spaceflight more like commercial air travel is today, and that is to say safe, affordable, and utilizing vehicles that can be flown over and over again. Over time, the primary benefit of these Block 5 upgrades will be the capability to achieve rapid reusability with high reliability. Block 5 is designed for 10 or more flights with very limited refurbishment, but should be capable of additional flights with further testing and possibly additional refurbishment after that. In addition to the changes that Michael and Lauren have touched on, we've also made changes to the 9 Merlin engines on the bottom of the first stage of the Falcon 9. The thrust of each of these Merlin 1D engines has been increased from about 176,000 pound-feet to 190,000 pound-feet at sea level, which represents roughly an 8% increase in thrust. We also have changed the primary thrust structure that houses these engines, which we call the octaweb, from a welded aluminum structure to a bolted structure. And this greatly reduces the manufacturing and inspection burden and increases reliability and shortens the lead time while in manufacturing. Additional improvements have been made to the landing legs to support rapid post-landing vehicle processing, and we've upgraded the operational capability of components across the board on the rocket. Some of the improvements we made have already flown on previous vehicles. For example, the titanium grid fins, which have significantly greater control authority than the previous iteration, were flown for the first time back on Iridium 2 in June. In addition, we've also flown an upgraded first stage heat shield, thermal protection tiles, as well as a new second stage new anti-vortex device, which is used to prevent the fluids inside the stage from developing into a whirlpool or vortex. The ultimate goal is to be capable of relaunching a flown booster within 24 hours with minimal refurbishment. That doesn't mean we intend to fly the rocket once a day, but we could if we needed to. Block 5 will be SpaceX's workhorse vehicle for years to come. It is the final substantial upgrade to the Falcon 9 design, although we may make minor upgrades as we continue to strive for rapid reusability and extremely high reliability.
As previously mentioned, Bangabandhu Satellite-1 will be the first Bangladeshi geostationary communication satellite for the country of Bangladesh. The satellite was built by Thales Alenia Space of France and fitted with 26 Ku-band and 14 C-band transponders. This allows the satellite to cover a wide variety of broadcast and telecommunication applications, including satellite TV, internet access, and emergency communication services, and much, much more. The satellite will be operated by the Bangladesh Telecommunication Regulatory Commission, or the BTRC. Located at 119.1 degrees east, Bangabandhu Satellite-1 will provide direct-to-home services, video distribution, and very small aperture terminal communications across Bangladesh. The satellite will also provide broadband connectivity to rural areas throughout the country. The satellite's mission is expected to last at least 15 years. The launch of Bangabandhu Satellite-1 is a key milestone for the country of Bangladesh, and to acknowledge this effort, we have a special message from the CEO of Thales Alenia Space, and its messages to the teams who made this mission possible.
Today is an important day for Bangladesh and for all of us. Bangabandhu Satellite-1 is, without any doubt, a pioneering and ambitious space program that will mark the history of Bangladesh. And I'm very proud of Thales Alenia Space to be part of this exciting story. Bangabandhu Satellite-1 is designed to reduce the digital divide in Bangladesh by providing broadcasting and communication services all over the country, and particularly in rural zones. This satellite will highly contribute to the economic development of Bangladesh. Being the country's first telecom satellite, it also represents the confirmation of Bangladesh's entry into the high-tech space sphere. And at Thales Alenia Space, we are delighted to contribute and make this happen. The teams from Bangladesh worked with us in a very professional and human way. We will never forget the emotional and decisive moment of a satellite's acceptance review in our clean rooms. The entire delegation, with a Bangladeshi flag in their hands, began to sing in unison in front of a huge silvery mass of the Bangabandhu Satellite-1. It's moments like these that really lend meaning to our motto, Space for Life. I would like to congratulate all teams involved for doing such a fantastic job. Thales Alenia Space teams for their large contribution and for having delivered the satellite on time, Spectra, our efficient satellite ground segment partner in Bangladesh, and SPI team for the close cooperation with our teams along the program. Finally, I would like to warmly thank BTRC for entrusting us with the first satellite. From beginning to end, you can count on Thales Alenia Space. Joy Bangabandhu, joy Bangladesh.
We're now at about T-minus 6 minutes and 30 seconds, and at this point, Stage 1 and Stage 2 are just about fully loaded with almost 1 million pounds of kerosene fuel and liquid oxygen. The second stage is 100% full of RP1 and about 85% full of liquid oxygen. The first stage is just under 100% of RP1 and at about 98% of liquid oxygen. We'll continue topping both stages off until about T-minus 2 minutes to keep the propellants as cold and therefore as dense as possible. That way we can fit as much propellant onto the vehicle to loft the satellite this afternoon. Around the T-minus 7 minute mark, we began our engine chill procedure. The propellants are much colder than the engines, and so it's important to get the engines to the correct temperature by slowly flowing propellant through them before ignition. Liquid oxygen in particular is so much colder that it would turn into a gas upon first contact, which would be a pretty hard start for the engine. The next major activities, the strong back, that's the white structure right next to Falcon 9 there, will open and slightly retract away from the rocket. It will fully recline as soon as Falcon 9 leaves the pad. At T-minus 3 minutes, we'll be performing an engine wiggle. That's double checking to make sure that the thrust vector control system is working properly. That's the system that allows the engines to steer Falcon 9 during ascent. At T-minus 60 seconds, you'll hear that Falcon 9 is in startup mode, which means that the rocket's internal flight computers have taken over the countdown. One more interesting change for this mission in particular relates to how we're using the Merlin engines. In Block 4, the engines were used with a constant chamber pressure. Because engine thrust depends on both chamber pressure and external atmospheric pressure, the engine thrust would slowly increase by up to 10 or 15,000 pounds per engine during ascent. The difference here is that for Block 5, we'll be maintaining a constant thrust of 190,000 pound force until cutoff, which means that we'll be slowly decreasing the engine's chamber pressures over time in order to compensate for the decreasing atmospheric pressure during that ascent. Again, for today's mission, we are looking to recover the first stage. This is the fully reusable version of the Block 5 rocket, at least 10 times reuse and potentially up to 100. The drone ship, Of Course I Still Love You, is currently on standby in the Atlantic Ocean, ready to catch the first stage during its descent. Bangabandhu Satellite-1 is currently looking pretty healthy. Entirely healthy, and we're excited to get that into its geostationary transfer orbit. The range is currently go, and the weather is also still looking good enough for us to launch today. At this point, we're just outside of T-minus 3 minutes, so let's listen in to the last few minutes of terminal count.
Stage 1, last load complete. Bleed verification. Strong back loader complete, 88.5 degrees. Stage 2 dump manifold secured. Stage 2 locks, throttle on back. Stage 2 locks load complete. Falcon 9 is on internal power. Gas closeouts is running. M1D fuel bleed complete.
AFTS ready to launch.
LV countdown, we've had a launch abort sequence start.
It looks like just after Falcon 9 entered startup mode, it threw an abort. We're currently looking into a little more details to see if we're able to continue today's mission. If not, we'll be using our backup day tomorrow at about the same time. If you're just joining us, it appears we had an abort thrown by the vehicle just after it entered startup mode. These abort sequences are important to make sure that the Falcon 9 is in its best shape in time for any launch. So we're much happier to take those aborts beforehand rather than continue when there's any risk to the vehicle. If we have to go tomorrow, we'll be checking to see exactly what was happening that threw the abort today. The backup launch window opens tomorrow at 4:14 p.m. Eastern Time, or 8:14 Universal Coordinated Time, and closes at 6:21 p.m. Eastern Standard Time, or Eastern Daylight Time, or 10:21 Universal Coordinated Time. Hang on for a few more moments. We're waiting for official word from the countdown net, and we'll get back to you shortly. Again, if you're just joining us, we had an abort just before our predicted launch time of 5:47 p.m. Eastern Time. These are an important part of making sure that the vehicle is healthy for launch. At this time, we are currently looking to discover the cause of the abort. We're still looking to discover the cause of the abort that Falcon 9 threw just inside T-1 minute. Because so many systems respond in an abort, they change to a safe state. It takes us several minutes to understand the generally single cause of that abort. The team is actively scrubbing the telemetry log as we speak.
CLD on countdown 1. Vehicle is safe. Please stand by while reviewing data.
You just heard on the countdown net. We're still reviewing the data to see if we're able to determine the cause of that abort. And you heard the launch director announce that the vehicle is safe and gave the OK for payload to go back to external power. So we're still reviewing those telemetry logs. We're not yet scrubbed for the day. We're working to bring you that information as quickly as possible. If we're able to launch today, or if we are not able to launch today, excuse me, then our backup window is at about the same time tomorrow at 4:14 p.m. Eastern Time, closing at 6:21 p.m. Eastern Time. We are still continuing to look at the data to determine if we can understand the cause of this afternoon's abort. Aborts are part of the standard process. Again, it's good to make sure that the Falcon 9 is completely ready to go, both the ground systems and the vehicle systems as well. And double checking those is vastly preferable to having any sort of a problem during flight. There's still a chance that we may be able to launch today, and we're working to see if that's going to be possible. Otherwise, we'll aim for a backup launch window tomorrow afternoon. If you're just joining us, we had an abort at the very final stages of countdown within 1 minute for a launch time of 5:47 p.m. Eastern Time. Falcon 9 through the abort, and they're part of the standard process. We're still continuing to look at the data to conclude, even if it was a ground problem or a vehicle problem. Because at T-1 minutes, the flight computers go into startup mode. The process of understanding that abort is a little more difficult than at other times in the countdown. So we're reviewing those telemetry logs to make sure that we're understanding it. There is still a chance that we can make it work for today's window, and we're currently exploring if that's a possibility. And if you're just joining us, you can see that it's a T-minus 15-minute clock at the moment in a yellow state, which means we're in a hold state. We threw an abort at just inside of T-minus 1 minute as Falcon 9 had taken control of the countdown. Those aborts are part of the standard process to make sure that everything is working just as we're expecting. Much better to have those sorts of signals on the ground rather than any time during ascent.
SCLD on countdown and officially scrubbed for today, preparing for 24-hour recycle.
And we've just received final confirmation that we are standing down today due to a violation of abort criteria. The vehicle and payload are in good health. The next launch opportunity is tomorrow, May 11th. Again, if you're just joining us, we had a launch attempt at 5:47 p.m. Eastern Time. Falcon 9 threw an abort in the final minute of countdown. And it seems like we are unable to reach the launch, or to launch within the launch window for today at this time. We have concluded a preliminary review, however, and have determined that the vehicle and payload are in good health, and will be aiming to launch tomorrow during our backup launch window at 4:14 p.m. Eastern Time, closing at 6:21 p.m. Eastern Time. At this point, we'll conclude the webcast. Thank you again for joining us, and we hope to see you for tomorrow's launch attempt at, again, 4:14 p.m. Eastern Time. Thank you again.